Mean absolute deviation, or MAD. So what exactly is mean absolute deviation? Let's take a look at what each word means. Mean means average. Absolute represents absolute value. And deviation means to stray. The mean absolute deviation shows you how far on average each piece of data in your data set is from the middle. How far does each piece stray or deviate from the middle? Well, let's take a look at what that might look like. So here we have a dot plot, and this was a survey of 10 students, and they were asked how many pets they have at home. So remember, each dot represents one of the students. So one student has 9 pets, one student doesn't have any, and one student has 1 pet. So what we want to do is we want to find the average of all these numbers. What's the average number of pets that the students have at home? So if I added up 9 and 5 and 5 and 5, if I add all this up, I'll end up with 40. There were 10 pieces of data, or 10 students were surveyed, and 40 divided by 10 is 4. So the average is 4. The average number of pets that students have at home is 4. I'm going to draw a line on our dot plot to represent the average. So what the mean absolute deviation is, how far does each piece of data deviate or stray from the middle? On average, how far is each one of these pieces of data from the mean? So that's what mean absolute deviation is. Let's see how you calculate mean absolute deviation, and let's take a look at how you use it. How do you use that information? Just a quick reminder, these are your measures. These are words that you can use to describe your data. These words describe the center, and these describe the spread. So we've looked at range. That looks at the spread of the highest to the lowest piece of data. And we looked at interquartile range. Interquartile range looks at that middle 50% and looks at the spread or the range of the middle 50%. Mean absolute deviation looks at how far is all the data from the middle. So these are all used to describe spread of data. So how do I calculate mean absolute deviation? Let's take a look at another example. So here we have 8 students that were surveyed, and they were asked, how many movies do you see a month at the theater? And of course we have 2 students that see 4 movies, and 2 students don't go to the movies at all at the theater. So the first thing we want to do is we want to find the average of all these numbers. What's the average amount of movies that these students go to in a month? So if you add up all the numbers, you'll end up with 16. And there were 8 students that were surveyed, 8 pieces of data. That means our average or our mean is 2 movies. So the average student sees 2 movies a month at the theater. Now what we want to find out, so here's our average 2. We want to know how far these other pieces of data, how far do they stray, or how far do they deviate from the middle, from the mean. So we're going to use a table to help us do that. I'm going to take all the data values and plug them into the table. And then we already know our average. Our average amount of movies was 2. And we want to know how far does all the data deviate from the mean? How far are all these from the middle? Well, 0 would be 2 away. 1 is 1 away from 2. 2 is right at 2, is right at the average. 3 would be 1 away. And 4 would be 2 away. So I'm going to add all these up and I get 10 because remember, mean absolute deviation. What's the average distance? What is the average distance from our middle? So we need to find the average of all these distances. So I'm going to take 10 and I'm going to divide it by 8. I take 10 and divide it by 8 because there are 8 pieces of data here. So the average distance from our middle is only 1.25 movies. That's very small. So the average from the mean, the other pieces of data, they're very close to the middle. So our mean absolute deviation is 1.25. Now here's how you use mean absolute deviation. If the mean absolute deviation is small, then you could go ahead when you're describing your data, you could use the median to describe your data, you could use the mean to describe your data, and they would both be fine. If the mean absolute deviation is really big, as you're going to see in our next example, then you'd be better off using the median to describe the center of your data. So we had our question up here, and it was, how many movies do 6th graders see in a month? I can go ahead and answer it. The answer would be 2 movies. And, I think I'm going to answer it this way. I'm going to say, on average, 2 movies. All right, let's look at one more example where the mean absolute deviation is going to be large. Some students were asked how much allowance they get in a month, and it looks like we have 10 different students, and you can see that one student makes a lot of money, $480 a month, and we have 2 students that don't make any allowance. So the first thing we want to do is, well, what's the average of all these 10? If I were to add up these 10 numbers, I would get 600, and I'm going to divide it by 10 because there were 10 pieces of data. So the average student, according to this survey, the mean or the average student makes $60 a month in allowance. So what we want to find out is, we're going to look at the mean absolute deviation. So if the average is 60, how far do those other pieces of data, how far do they stray from our average? How far away are they from our average? So again, we're going to use a table to help us figure out mean absolute deviation. I'm going to take all this data and plug it in. And then our average amount of allowance was $60. So I'm just going to draw a line here. So our average was 60. So how far does 0 deviate from 60? What's the distance from 0 to 60? Well, it's a distance of 60. What about 10? Well, 10 would be 50 away from 60. And 20, these are all going to be the same, would be 40 away. This is always going to be a positive number. It's the absolute value. It's the absolute value, the distance from our average. And then 480 is pretty far from our mean. That probably would be considered an outlier. So that's 420. Now we want to know, remember, mean absolute deviation. What is the average distance? What's our average distance from the middle? So I'm going to add up all these numbers. And if you add them all up, you get 840. And I'm going to take 840 and divide that by the number of pieces of data. So that's 84. So the mean absolute deviation is 84. So let's think about that for a minute. If the mean is 60 and the average piece of data is 84 away from that, that's pretty far. That's quite a spread. So you probably don't want to use, well, in fact, if you look at 60, does it describe this data? Would you say the average student makes $60 a month in allowance? Only one student makes more than 60. So that would be a bad descriptor of the center. Because our mean absolute deviation is so large, if you were describing this data, you're better off using the median. So let's see what the median is of this data. Now the data is already in order from least to greatest. So if I look and I find our middle, our median is $20. And that looks to be a much better descriptor of the average student. So to answer our question, how much allowance do 6th graders get a month? I'm going to say the median allowance is $20. That's a much better answer to our statistical question than saying the mean is 60. So that's what mean absolute deviation is and how you can use it to help you describe your data.